So we'll have another short week. So we'll have a couple of weeks of having 2 days and then another short week. We'll get everything all figured out. And then after that, we just have 2 weeks before spring break. So everything just moves along very quickly. So I hate to change dates because it can get things all confused. But I did because we had so much going on. So if you've noticed, your week 4 raffle and the triangle assignment that we're due tomorrow night, our normal Tuesday night weekly assignment, those were moved to Thursday night. So you'll have class today and Wednesday before those are both due. Now, you don't want to put those off, though, for that long if you don't need to. So if you can get them out of the way and turned in, that's going to be best for you, because our Unit 1 exam and our Unit 1 hands-on, you guys did not get an opportunity to give input into this decision. I apologize for that. The afternoon class was here, and I thought, well, you know, we could just make this exam something that gets done at home so that we could use our class time for practicing and doing some more with our looping statements. And so we did a vote, and doing it at home won. So we decided that you guys would probably have voted about the same, so it would have come out. So the Unit 1 exam, you're supposed to do at home on your own. Now, just like you were taking an online class, you're going to follow all of the rules that are posted for the exam. You have a practice exam available. It says you can use 1 page of hand-printed notes. Don't look at the practice exam and make that your notes. That's not what it means, okay? So it means you could have notes about the content so that you could use those notes to help you answer the questions in the exam. So just like if you were taking an online class and you're going to make sure that you abide by the rules, make sure you do that for our exam, even though we're not going to have it in class. So that way we're not going to spend a whole day worried about that exam here in class. Now the hands-on component hasn't really changed, nothing different about it, but both of these are due Tuesday night next week. Oops, no, let me change that. Look at me changing things. Hate changing dates. I have date dyslexia and I get all confused. Sunday night. And I made these due Sunday night, which is an unusual due day for me, because usually you put everything on Tuesday. Like I said, my date dyslexia, that helps if I know when everything's going to be due. I don't have to worry about it. But I thought, you know, we're having a little trouble here this semester with things dragging over into the next week and us not being able to start on our new topics like we need to. So we're just going to nip that in the bud and say this is due Sunday night. Starting Monday morning, we're going to be looking at creating methods and subprograms, which is our next topic that we need to get onto. So that's where we are. Yes, sir?
What is the hands-on?
Well, take a look at it in Canvas, and you should be able to figure out exactly what you need. See if I have it open in 57 places. So if you go take a look at it, now the hands-on is going to point you to a hypergrade assignment. Basically, you're going to be doing the Fibonacci sequence. And the Fibonacci sequence is a math equation that we can actually apply to bunnies, right, and how quickly they reproduce, so that we can figure out in 3 generations, these 2 bunnies will become how many bunnies. So in the assignment, it gives you the specification for how to do the sequence. And then it would like for you to refer to the hypergrade for the exact required output. I'm going to take a look at it. View required output. So it's not got a lot of output, but it does have a little. The welcome message, prompts for how many generations the user would like to estimate. That is read in and validated, right, to make sure it's numeric. And then the calculation is run to say what the fold size will be after that many generations. So you need a little bit more looping experience to be able to complete this one. Let's take a look at it. Now, it should not be a hard assignment for you, but it depends a lot on your background. So if you've had some other programming classes before and you're a really logical thinker, you might just approach this one super easy. But if things are being hard for you, having a hard time adapting to the C# syntax, making you not be able to focus on things logically, then take a look at this and do the important parts first, right? Do the calculation with some sort of hard-coded number. Then add in the information to prompt the user for a number. Then add in the final looping to say, do you want to do it again? And if you do that, then your hypergrade output is maybe not going to match, but I'll be able to tell when I look at the assignment what you have so far, and I always give you partial credit. Now, when do I not give you partial credit? When you delete the assignment from hypergrade completely, and there's nothing there for me to look at, because then I don't have anything to look at. How can I give you any sort of credit whatsoever? And we've had a few people this semester that are doing that. So don't do that. If it doesn't work in hypergrade, at least leave it there for something to see. Now, we should be prepared to do this one without any problem, but we do need today and maybe Wednesday to get there. So let's make sure that we continue working with all of our loops so that you really feel confident about doing this assignment. Now, before that one is even due, of course, we have our actual assignment for week 4 that's due on Thursday, and that's this 4 triangles. Now, in the 4 triangles, I'll look at it in hypergrade, so much jumping around. You'll see you're just going to use some asterisks in some loops to create some triangle shapes. So you'll probably want to use a for loop for that. And last time we were just looking at while loops, so we need to get to for loops so that you know how to approach this one. So some of these right now, looking at them, seem a little bit challenging, but we'll get that there to where they're not. So the last time we were working on our Chapter 3 while loops project. Can you find that and get it open? We'll go back and look at that assignment later and see if anybody has any questions after we've had a chance to do a little more practicing. You know, the REPLs themselves are designed to help you get to where you're ready to complete that assignment too. So both things are practicing hands-on in class and looking at those. Doing the REPLs are designed to help you get used to the C# syntax, get to where it's not a problem for you anymore. Because I know it's not a matter of your logical thinking, it's a matter of the C# syntax. When you're doing the REPLs, don't forget, they're designed for you to submit them and then email me. Now, they're not designed for you to say, oh, doesn't work, submit, submit, submit. That's not what they're designed for. They're designed for you to try to figure it out. And then if you can't figure it out, submit it to me and send me an email telling me that you've submitted it. If you don't send me an email, I won't know until I just happen to go look at all of the REPLs. The other day when I looked, there were 8 or 10 assignments that had been submitted with questions, and I hadn't gotten any emails about any of them. So please do send me emails so that I know those are out there. I've asked the REPL people to change that setting so that it sends me an email, but so far they haven't. All right, we have these great projects in Visual Studio that we've created. We created 3. We have our basic while. Let's take a look at the CS file for our basic while loop. Now that's pretty easy. I have my OneNote document open, so I want to copy and paste this whole thing in there. Now, in my OneNote document, I've got to create a tab here for this. I'll call it looping. I know it's actually iteration according to all of our textbooks, but I still feel like looping is better for me. So I'm going to say this is while loops. And I don't really want to copy and paste this code into my OneNote. I want a screenshot of it because I'd like to keep the color coding and all of that stuff. So I'll bring up the snipping tool. Oh, you know, I don't even need the snipping tool, do I? Let's go back to OneNote. In OneNote, if you look at your insert menu, on your insert menu, you can actually choose screen clipping, and that'll bring up the clipping tool. And then you can just do a screen clip right from within OneNote. Fancy, huh? You can actually do that within Word now too, so just hard to remember that you can, but it's super handy. Okay, so I like that now. I have my color-coded code. Now, I wouldn't be able to copy and paste that back into Visual Studio this way. So realize, you know, the drawbacks of doing it as an image versus copying and pasting the code. But I do like that I have everything here. It's nice and color-coded. So now I could put some comments on this if I wanted to without making my code all junked up if I just do it in OneNote. So let's do some things. I'm going to go to the draw menu and let's see, I'll do, I don't know how exactly I want to do it. I think I want to do a box or something. Oh, you know, I like those call outs. Let me do this drop down. See what all kinds of things I've got. Don't have too many of them. I'll just do a box. So I'll put my box in here and put some text in here and say namespace defines the entire project or something like that. Now let me highlight all that and make it a color I can see.
How do you insert a text box?
I went up in the draw menu to this shapes area, and then I just used the rectangle, and when I double clicked on it, it let me put text in it. So I didn't find an actual text box.
Oh,
So try it and see if something else works better, because the greatest thing would be like if you had a touch screen, because then you could just type, you know, draw some things on there, some words on there or whatever. So here's my namespace. I'll put that comment up here, and then since my shape was kind of a pain, I'll copy it and paste it. I want to paste that whole thing, you silly thing. There it is. It's not doing very good at keeping on top of that picture. So decide how you want to do it, and maybe best to do it beside the picture. Get it back in there. Now I want to put some more notes here. I'll just grab my little, I'll just put some here. Here's my class statement. My class statement really keeps functional components together. And then any other notes that you want. Now, what's important though in this program is our while loop. So I'm going to put a little bit of a comment down here. While loop syntax. And then I want something like while, and then within parentheses is my condition. And then I want opening and closing curly braces. And inside my curly braces, I'm going to have my while loop body. And I want to make sure that my while loop body is indented. And I want this W to be a lowercase because in my notes I need it to be correct. Now that gives me a nice while loop syntax example that I could make a much bigger font if I wanted to. Keep that in my note. So now I've got my while loop syntax. Now a couple of things. Whenever I'm grading, I want to be able to give you guys comments that help you program, like, you could have done a loop here instead of repeating this code, or this would be a great place for a method, not to be critical or anything, but just so that you think about how you could have done it a little bit differently and maybe it would have been better.
Constructive criticism.
Constructive, right. And then when I see things though, where we don't have code indented properly, that's just plain old criticism, right? Because that's like, you didn't do this properly, and that'll be a point deduction. Right? Because who wants to be the programmer that has to follow up and look at some code that's not properly indented? That's like trying to read some sort of novel that doesn't have any periods or semicolons or any proper punctuation in it. It makes it really hard. And so every once in a while you might find a novel like that that's done that way on purpose, but then you're expecting to read this mess of jumbled up stuff. If you picked up just a website or something that has no punctuation whatsoever, you probably won't spend much time reading it. If your code is never organized properly, no one else will want to use it. And that means that the company that you work for might not want you working there anymore because no one wants to look at your code. So indenting is actually very, very important because it keeps your code structured and makes sure that other people can follow it. So there's a nice while loop for us. We did this while loop and just said while true. Now we could also copy our other code in if we wanted to OneNote. So let's look at while loop fun. Now in our while loop fun, I'm not going to copy mine in there because you can see I'm impaired when I work on things like that. But I want you to think again about those options that you could copy and paste and make some more comments if you wanted to. Things that are meaningful to you. How do you interpret this? What's something that would help you remember how to use it? Now in our while loop fun here, we just asked a question, what would you like to do for fun? And we asked for a special word, the word done, to be entered when we wanted to end the loop. And so we just continued asking for what we would like to do for fun. We printed it out, and then we prompted for another option. So just another really basic while loop. In this while loop, we actually had an if statement nested inside of our while loop, which is no problem. We can do that whenever we want. Now our while loop sum, we went a little bit further in this one, right? This one started getting pretty serious. Here we actually said, we would like you to enter a number and enter the number -1 to quit. We decided at the very beginning that we didn't want that -1 coded throughout our program everywhere because that would be poor programming style. So instead, we declared a constant to hold that value. And we named that constant Sentinel because that's our Sentinel value. That's when we're going to end our loop. So then in our output, we could use that variable. And in our while statement, we could use that variable. Now in our while loop, we added an if statement to check to make sure that the number they entered was a valid integer. If it wasn't, we asked them to try again. If it was, we converted it, well, or actually we just added it to our sum and output it to the console. When our while loop was all done, we wrote the sum of all of our values out to the console, and then we issued a read key statement. So notice that this write statement comes after the end of our while loop, Again, our opening and closing curly braces, helping us to figure out exactly where those things are starting and ending. So cool. So we see a while loop. You write that up here. While condition, and then our while loop always has the exact same syntax as an if statement up here, right? Just the condition is coded exactly the same as it would be for an if statement. We just use that word while instead of the word if. Now, when we're looking at this while loop, a couple of things about a while loop that we should keep track of. When we're using while loops, these are top controlled loops. My box here is in my way. Stupid box. So I'm going to put some notes over here somewhere and clean that up later. So while loops are top controlled. That means that the criteria for whether or not they'll be executed occurs at the top of the loop, right? While loops may not, the while loop body, let me get this in here, may not be executed even one time if the criteria is not met. Got this weird green box that I can't get rid of. Go away, green box. There it is. There it is. Okay, so if our criteria is not met, we're not going to execute that loop body, not even one time. So if we have something wrong, that's going to keep our loop from executing. So we need to make sure that our loop is properly set up before we execute it, before we start. So in order to make sure that it's properly initialized, we have some things we need to take care of. First of all, we have to declare a control variable for our loop. Now our control variable must be initialized. So that our loop will execute, and our control variable must be updated to end the loop, right? Otherwise we get one of those infinite loops that doesn't ever end because we didn't update our control variable. So three things that have to always happen for a loop. We have to declare our variable, initialize it, and update it. Let's look at our code and see if we did that. Here's our last one, our sum loop, our more important one, the one that did some serious work. We started out with our loop control variable, which is basically our user number, right? Because we could say, well, my loop is being controlled by the user number and the sentinel, but the sentinel's never changing. So it's something that we're using in comparison, but we're controlling our loop with this user number. So if the user number is not equal to sentinel, we'll execute our loop. And then we're updating our user number in the loop by asking our user to type in a new number. So we're always getting a new one. So everything's happening. So let's try a do loop. Let's create a new project. Remember, you go up to your solution. And I'm going to add a new project. And this is going to be a console app.NET framework. And I want this to be a do while loop. All right, everybody good? Let me rename our program.cs file. So instead of program.cs, I want this to be named do while. And yes, I want to rename everything Let's just create a really small one here. So in this case, we're going to create an integer named sum, and we'll set it equal to 0, and an integer named number, and let's set it equal to 11. So we'll just kind of do this loop 11 times. Now with our do while syntax, we start out with the keyword do. And then we have our open and closing curly braces. So with a do while loop, it's kind of harder to not have open and closing curly braces. You can still do the one line of code, but not really. It doesn't work very well. So it kind of forces you to have your curly braces. So let's say in this one, we're going to add to that sum. And I'll just use the long syntax instead of using the plus equal like we did in our other program. Now, sometimes in giving you different options can be confusing, but I want you to see where these things are really the same. Now I'm going to add to the sum, and then we're going to add to our number that's controlling our loop. Now, the end of our loop comes after the closing curly brace. We put the keyword while, and then our condition. We really want our number to start at 1 the way this loop is set up, don't we? Something backwards there. Now, this while is going to be so wrong. It does everything in so many ways wrong, because now I've got to have a closing semicolon. And in all of our other while loop and if statement syntax, we never have a semicolon on those statements. So this do while is just a little bit different. So don't let it mess you up. Now for this program, let's go ahead and put in a console.writeLine. And we'll say sum of the values. And I'm going to add more and go to a next line. 1 through 10. This little program's not going to do much here. Let me get out of the way so you can see this. Now, a few things. I left it console.writeLine because this is going to be our only line of code that uses the console, so it's not worth adding the use static statement. Also, I want you to remember that that's what it's going to look like if we don't have that using static statement. Now, the last thing I want on this program is my read key. But I have to put that keyword console on there, huh? Now you should be able to run that, and let's see if we get the right output. Whoops. What do I need to do to make it run that program?
Do while loop as your startup project.
Yep. So I'm going to right click on it, set it as my startup project, and run it. It says 1 through 10 is 55. Is that right?
I don't know. I'm not an algorithm.
I know. I don't know either. Should be right. We started out with some things that look right. We could use the debugger and make sure. Let's try it. Now, with the debugger, you've looked, yes, sir?
I said 11.
You said it's 11?
Yeah, it said 55.
Okay, so let's put it in the debugger. Now, we've looked at the debugger just a little bit. We'll look at it a lot more. whenever we want to make our code stop in a place without canceling, we can actually enter a breakpoint. So far, we've looked at the debugger when our code is canceled. I want a breakpoint, meaning I want it to stop executing my code when it gets to this do statement. So I'm going to come over here to this left area, to this gray line, and click. To get the right place, I think I'm one. That's where it wants to go, so I guess that's where it goes. Now, that red spot there indicates that there's a breakpoint set up in my code now. And that breakpoint says, when I'm running, I'm going to stop here to let the debugger take control. So now that I've got my breakpoint set, I should just be able to start executing my program, just normal. See if I can reach that. And if you saw, the console flashed up. Now the console is still active. It's minimized down here. But the debugger has taken control. Now I can tell that the debug session is active because I see my red spot that has that little yellow arrow in it now. That's showing me that the debugger is looking at this line of code. It's going to execute it. Now my do while loop, is this a top controlled loop or a bottom controlled loop? Bottom. My test is at the bottom, right? So right now, it's sitting at that curly brace just ready to execute this body because it knows it's going to, because there was no criteria there for that do condition. So now I have some things I can do to get Visual Studio to go ahead and execute my code. Before I do that though, look around at your screen. Down here, you should be seeing your locals window showing you all of the variables that are declared in your program and what their values are. So right now I have sum that has a value of 0 and number that has a value of 1. Over on the other side here, this far right, we have our diagnostic tools. Those don't usually mean a lot to us right now, but they could eventually. We saw that that infinite loop could use a lot of memory, so if we see anything weird going on over there, it could indicate some sort of problem. Now, I don't want to click continue because that's just going to run my program to completion. What I want to do instead is use these debugging tools here that are available now on my toolbar because I'm in a debugger session. And the one I want to use is step into, and step into is going to step into each line of code. So right now, since it's sitting at that opening curly brace, if I click step into, it's going to execute that line of code, which isn't really going to do much. Move me to the next line. Now I can also execute step into by pressing F11. So now I'm sitting here ready to execute this line of code that's going to add to my sum. So check your variable values down here. Got 0 and 1. Now press F11 or step into to execute that line of code. And you should see your sum change, right? So it executed it, added number to it. So now it's 1. So now if I step into again, I'm going to add 1 to our number value. So now it's 2. Now I am sitting at the while condition. So our condition is going to be analyzed. Is number less than 11? Yes, it is. So we're going to go back up to the top of our do loop and execute it again. We're going to be adding number to our sum and adding to our number. We're going to check our condition, see that it's true. So we'll execute our loop again. We're going to add to our sum, add to our number, check our condition, see that it's still true, execute our loop again. Now notice we're up to 6 and 4. Keep going, add to our sum, add to our number, check our condition. Now we can do this debugging over and over until our condition finally becomes false, in which case we'll fall out of this do while loop. So notice that we're going to execute this do while loop as long as the condition on the while statement is true. Sometimes when we're testing and debugging, We want to use really small numbers for things like that, right? So we can just step through it and see what's going on. But now, I see that I got through my while loop. I'm finally on the other side of it. So my condition became false. I'm now executing the next line of code that says, do a write line. And in this write line, output all this information. So if I execute this line of code, I should see that it's sitting on my console screen. And then if I execute my last line of code, my read key, we shouldn't really see any difference, but our console screen should pop up and show us what's going on with it. Okay, so if I want to then undo my breakpoint, I'm just going to go back to that little gray bar and click that red spot to turn off the breakpoint. Now, lots of other ways you can turn on breakpoints. You can just right-click on a line of code and add a breakpoint. You can use your debug menu to add a breakpoint. But notice that Visual Studio makes it super, super easy. That's why Visual Studio is one of the best IDEs out there, because it has such a great debugger. It really helps you a lot. Whenever you're learning to program, nothing will help you as much as using the debugger to figure out where your problems are and where your issues are. So whenever you have a problem, that's one thing that I'll ask you. Have you tried running it in the debugger to see what's going on? So you can't use the debugger in REPL. That's one reason why from the very beginning I encouraged you to copy things back and forth from Visual Studio to REPL. I think it makes you more aware of those little teeny differences that you have in the code that are important. And it makes you be able to use the debugger if you want to in Visual Studio. So it's a great, great thing. Speaking of REPL, when we're on loops, I mentioned last week how you wanted to save often in Visual Studio, because if you created an infinite loop, you could actually lose some of your code in Visual Studio. It doesn't happen very often, but it can happen. Well, REPL seems to have the same kind of issue, doesn't it, with loops? So if you create some infinite loops, you could break REPL. I did, I think, too. But we hope that you don't actually break it all the way. But do refresh that website, that web page, if you're getting like trying to connect to server, weird errors like that. Often if you just refresh, it'll make all of those problems go away.
I was just raising my hand to say that I have lots of experience of that. I've done it 4 times now.
Quit
So
it.
don't do
They're
it.
going to start charging me, saying all these students doing these infinite loops. No, I did it too. It doesn't, since they're running all virtual machines, it tends to throw their little virtual machines into some sort of fit. But if you refresh, I think you can actually get assigned to a different virtual machine if yours has now gone wacko. So do refresh. Now, the other night, there was a problem in there where it was like saying people's code that didn't even exist was causing errors. Sometimes REPL's broke, you know, and in that case, I couldn't get anything to work either. So hopefully we refresh. Sometimes it's just not perfect. All right, so that one's good. Everybody see how to do that do while loop? Let's get that one closed, as they say. I'm going to put that up here. So we saw that our while loop is top controlled. Our do while is bottom controlled. So that means that the code in the loop body, will always execute at least one time. So no matter what the value of our conditional criteria is, our code will be executed at least once. I'll put that in one note here. I'll say do while loops are bottom controlled. The loop body will be executed at least one time. Now, with a do while loop, we have the exact same thing going on as we do with the while loop as far as setting up our criteria variable. So no matter what, whether we're doing a do while or just a regular while, we still have to declare that control variable to run our loop, initialize it, and update it so that we make sure that we're getting a way to exit our loop. So if we look at our beautiful creation that we just did, number was controlling our loop. We initialized it before our while statement. Oops, I'm looking at the wrong line, sorry. Where is it? Here it is. So number again is our control variable. We initialized it before we go into our loop, and as part of our loop logic, we update it. So we make sure that we can exit that loop at some point. If we didn't update that variable, we would never get out of our loop. Now the while and the do while are the standard while kind of loops that we see in C#. So they're very, very helpful to us. Now let's look at some for loops. Find my project here. Right now, the project that we're working on is named Chapter 3 While Loops. Well, that's all great, but I think we've got enough stuff in here now for all these different while loops. Put notes, however you want to update things with comments in there, but I want to close the solution. So I'm going to use my file menu and choose Close Solution. That'll close everything out so that I have a brand new Visual Studio instance to work with. So now I'm going to create a new solution. It says New Project. That's my only choice. I want this to be a console app. Just like our last one, though, I want to change our names a little bit. I want our solution name to be Chapter 3 for Loops. And let's name our first project Basic for Loop. To keep everything clean, I want to rename program.cs. Yes, sir?
They won't let me make a new solution.
Oh, okay. Hang on. Let's see what's going on. I'm going to name this Basic for Loop. We made our solution be Chapter 3 for loops, and then we made the project Basic for Loops, the top one. And then we're just now renaming our program.cs to be Basic for Loops. Now we said whenever we loop, we need a control variable. And our control variable must be declared, initialized, and updated. I think I'll change this a little bit and say initialized, tested, and updated. Either way. All right. So in our for loop, we're going to do that with one variable, and we can do all three of these things within our for loop itself. So in a for loop, we start out with the keyword for. The first part of our for loop is the initialization part. So I can actually declare a variable. Let's declare an integer named I. And then my initialization part ends with a semicolon. After the initialization part, I have the test part. Let's say we're going to run this loop while I is, oops, I didn't initialize him properly, sorry. I'm going to set I equal to 0. Now I want to run this loop while I is less than 10. And every time my loop executes, I want to add one to I. I'm going to type I++ because that adds one to the variable. Now I'm just going to do a console.write line that says I is, not is, I is. And then we'll output our value of I. Now, in order to make sure that we're sure where things are starting and ending, I'm going to put a comment here, end of for loop. The closing curly brace after that is going to be the end of my main method. My pink one is the end of my class. And my orange one is the end of my namespace. So after the for loop, I want to open up a line of code and do a console write line. And just say something like loop ended. And then I'll put our read key. Now let's run it. We should see all of our different values of I, because we said that's what we wanted to output. Now we could actually make our for loop syntax a little different. Let's try splitting it up. I'm going to put each of these parts of the for loop on their own line so that I can put some comments and say declare int I and set it to 0. So notice how the for loop actually has these embedded semicolons, which can be really hard for new people, but it's because the for loop is doing these different functions. So then this is going to be test the value of I, followed by a semicolon. And finally, how to update I. So that part doesn't have a semicolon. So the syntax is definitely interesting, causes you to pause. Now, a couple of things about the for loop. I can leave any of these three parts out, but then I have to have the semicolon already in place. So let's try one like that. I'm going to create a new project. We'll try to make it really fast and simple like that one. Let's call it parts of for loop. Now in this one, I want to rename our program.cs parts of for loop. And in our last one, if you notice, we never even declared any variables because we were able to do all of that within our for loop. We didn't have to do anything else because the for loop allowed us to declare that integer. But we could do it a little bit differently. We could say we have a number that is 10. And then we could have a for loop that doesn't have any initialization part, that just says it wants to run while num is less than 20, and it wants to add to num. Now for this one, let's do our same console.writeLine. And let's output a value of num. And then end of for loop. We'll write out a message that it's the end of our loop. And do our console.read key. And I'll label the rest of these closing curly braces. End of our main method. End of our class. And finally, the end of our namespace. So in this for loop, we've left out the initialization part. Now, would we be able to leave out the test part? Probably not, because then we wouldn't have any way to end our loop, right? We'd just be code. But we can leave out the initialization and the incrementation. All right, run it and see if it works. Work. All right, so we can use our for loops. They give us a lot of flexibility. So they can be kind of difficult at first when we're just getting started, but they can really, really give us a lot of things that are really great. Let's do a box because we want to kind of think about that triangle thing that's required, and then we'll stop for some lab time. So I'm going to create one more new project, and we'll call this for loop box. Won't be as cute as your triangles. I want to rename this .cs file for loop box. We could set up a constant integer that would be the size of our box. And let's say that it's going to be 10. So that to me means 10 rows and 10 columns. So 10 by 10. What do you want to use as a character? We use the star in the assignment. Let's do a percent sign. How's that? Now we don't have to set these up as constants, but we can. So gives us an option. Now for our for loop, let's say we're going to start out with doing a box where we have 10 rows and 10 columns. So that means for each of my for loops, I'm going to have a nested for loop here. I'm going to want to have something that tells me how many rows and how many columns we're going to have. When I'm working with the computer, I do a cross a lot easier. So those columns are going to be my inner for loop. So my outer for loop is going to be rows. So I'm going to start with row 0. Do you want to start with row 1? Doesn't matter, as long as we make sure that we're doing the right thing based on how we started. Now we want to execute while rows is less than or equal to 10. Oops, I want to do 10 there, do I want to use my size of box variable? Ah. So I could put a variable name in here in any of my testing conditionals. And then I want to update my rows variable every time my for loop runs. So this is what I'm going to do for rows. So now for each column, I can start out that my columns are going to start at 1. I want to execute while my columns are less than or equal to size of box. And I have to update my columns. Now there's a couple of different ways we could do things. So let's just do, to start, a console.write. And we want to output just that box character. I'm going to label my closing curly braces. Now we could say that this is the end of the for that has to do with columns and the end of the for that has to do with rows and the end of our main method and the end of our class and finally the end of our namespace. Lots of them. Now I have some problems here. It's not ready, but we could test it. What's going to happen? I'm going to get a whole bunch of percent signs just in a row, aren't I? I better put something in to hold my console open. I want to put that after my outer for loop. Because I want to see this mess I've created. Now if I run it, did it again. Let me fix it so my box is my startup project, and I run it, and now I should see a whole bunch of percent signs. Well, that didn't do me any good. What am I missing?
The ability to make new rows.
Where do we want to make a new row? After our inner for loop? Does that be a good place?
Mm-hmm.
So what we could do a lot of different ways here, but we could just use a console.write and output that new line character, that control code if we want to. We could make it be a console.write line and have no data in it if we wanted to. Let's run it and see. Oh, that looks better. Not very good box, is it? Because percent sign's not the greatest of characters, but it works. But we could change it really easy because we made it a constant. So if we don't like that percent sign, we can make it a pound sign and see how that works. And it's still not too boxy looking. With that console, sometimes it's a little bit hard to get that. Now, what if I wanted to do this a little bit differently? I could actually put everything in a string. So let's do that before we do our lab time. Let's say we're going to create a string named output, and we're going to start with it being an empty string. Now, instead of doing a console.write, I want to add to our string plus equal box char. And then within our loops, after our inner loop, instead of doing a console.write of that new line character, I want to add that new line character to our string. Now we're building that whole box within this string named output, bless you. And at the end, after our loops, we can write out our output. Now, when you're working on your stars doing the triangle, you could do it either way. But let's make sure this works. Same difference, and you should see it the same. Good. Everybody's work okay? All right, let's have some lab time. Now, today I want to just do independent. I know some people have got the REPL thing almost done. They're going to get out of here. Some people have got the REPL thing not started, so they're going to get to work. But remember, you should be working on the week 4 one for looping. That's the one that is due Thursday, and it'll help you with your looping program. Now, if you have gotten behind on any of the others, you're going to want to get them done because they're going to really help you with some other stuff. And we'll be doing less and less of them as we go. We get past all of this basic syntax stuff where you don't have to worry about that quite as much. But let me know if you have questions, and I'll help. Any questions about this? Yes, sir?
Well, this is about hypergrade. If you try to turn in an assignment and it doesn't match the output exactly, is it still turned in that progress?
Mm-hmm.
Okay.
So you want to just make sure you turn it in Canvas so to let me know that you were there, because sometimes I'm not sure if people were done. So I just like that confirmation in Canvas that I'm done.